work in the project Alchemia. React is first of all, we would like to mention that we are going to record this meeting, and then you can also share this interesting webinar with the rest of your colleagues. REACT is the acronym of Resource Efficiency Automation for Circular Transformation. It's a collaboration of projects from the UE Green Deal cluster, namely Alchemia, Greener, Tubers, Reclaim, Clarus, and Boot-to-Boot projects. For this session, we are also counting on the participation of Antonius Rosreder, who has been invited due to his background and relevance to the topic that we will be discussing today: workforce upskilling and talent retention in the industrial sector. This is the agenda for today's session. Please address your questions through the chat or even verbally after each session, or maybe if you have more questions, you can address at the end of the session. We will start with Forging the Future, Upskilling for AI in the Steel Industry by Dean Stroud from Alchemia Project. Dean Stroud is professor in Skill and Workforce Development at the School of Social Science at Cardiff University. He's currently principal investigator for Cardiff University to the U Horizon project funded Alchemia, and publishes sector-based account for skill formation, the labor process, industrial relations, and greening industry and Industry 4.0. Please, Dean, the floor is yours. Thank you.
Sorry, I didn't realize I had my mic on. You see the presentation?
Yes, but not with the presentation screen.
Yeah, I was going to just open it up now. I just wanted to make sure it was there. Right, is that okay?
Yes, thank you.
Sorry, so I can't see you. You're not on my screen. So I didn't know if anyone was putting their thumbs up or not. So yes, thanks for the introduction, Irina. Yes, my name's Dean Stroud, Professor of Social Sciences actually at Cardiff University, specialising in skills and workforce development. And today I'm going to be speaking to you about the Alchemia project and upskilling for artificial intelligence in the steel industry. So what I'm presenting is based on the first stage of the human factor research conducted for the Alchemia project. And that research is conducted by myself with my colleagues from Cardiff University's School of Social Sciences, Martin Vinal and Rachel Hale. So first, I want to say something about the Alchemia project, which, to give you its full title, is the Data and Decentralized AI for a Competitive and Green European Metallurgy Industry. It's funded by the Horizon 2020 funding stream and runs from 2022 to November of this year. The consortium involves 2 steel industry firms, 2 academic partners, a dissemination partner responsible for organising today, and a range of technical partners, with the managing partner being Eviden, formerly Atos. In short, the overarching aim of the project is to optimize the scrap mix for electric arc furnace steel production by means of machine learning, incorporating aspects of federated learning, which is for preserving proprietary knowledge, and continual learning. Its broader aim is to incorporate Industry 5.0 and human-centric manufacturing, rather than the more technologically deterministic kind of approach for Industry 4.0. So it's a move on from that, although we might think of AI also as an aspect of Industry 4.0. We look to prioritize the human aspect. So to this end, it adopts a focus of human-centric design, or HCD, and seeks alignment with the high-level expert group of trustworthy AI framework, ALTI. Once completed, the Alchemia platform will be employed at 3 electric arc furnace steel production sites of one company and 1 automotive steel production site making automotive brake discs using a cupola furnace. The broader aim of the project is to scale Alchemia up and the platform up for the European metallurgy industry. The focus is on the steel industry because it is a highly polluting industry and needs to be more efficient. When I talk about pollution, I'm really talking about carbon emissions. So it has some of the highest global carbon emissions by industry globally. The most polluting means of production is blast furnace technology, but even in the cleaner electric arc furnace technology, that can become greener too and more efficient. So hence this project focused on that. And we're seeking for optimization and efficiency through Alchemia. Of course, that will take place alongside other means to decarbonize the industry more generally. But as with any technological innovation, such as Alchemia or artificial intelligence more generally, of which Alchemia is, it carries implications for the workforce. And this is where Cardiff and the Cardiff research team comes in to help understand those workforce implications, what it means to introduce an artificial intelligence platform into the optimization of electric arc furnaces, what that means for workers, the skills, the way they organize work for those workers, and all the implications that flow out of new technology implementation. So we were tasked then with researching the human factors of technological change, and this platform particularly. As I mentioned before, there are 4 research sites overall, 3 steel plants, and these are based in France, Poland, and Spain. And the 1 automotive parts factory is in Italy. There are 2 distinct phases of the research, and what I'm discussing today is based on the first phase of research, which was conducted in May and June of 2023. We conducted interviews and surveys at each plant to collect worker and management perspectives on the introduction of the Alchemia platform. And later this year, we'll go back to the sites to ask about perspectives following the insertion of Alchemia and how it works in practice. So essentially, we wanted to get attitudes before and expectations of the platform. And then once it's inserted, how does it actually work in situ? And across this, we're asked to deliver, we were asked, at least for the first part of the research, Work Package 2. The second part is connected to Work Package 5 of the project, but Work Package 2, we had 2 deliverables. One was reporting on the research findings of the attitudes towards the technology and making recommendations on enhancing human-centered design for the development of Alchemia. And second, we developed a strategy for meeting what we understood to be the emerging skill needs for artificial intelligence. More generally, attitudes to artificial intelligence more generally at the sites we visited, and for Alchemia specifically. So from the research data, we note the capacity for steel workers, capacities to be generally augmented. So there are dangers of cognitive complacency and de-skilling because the platform makes decisions for workers working in the background. And in that sense, they may become de-skilled to some degree. But we also noted the potential for upskilling, as well as knowledge enhancement and widening skills profiles. And we can see from the interview extracts on the slide there that the participants in our research discussed the need to adapt to new times, and that this included skills of leadership, data management, data analysis. Other interviewees suggested a need for transversal skills or soft skills. This including social and personal skills, methodological skills, digital and environmental skills. And I'm going to say more about those and what informs our understanding of transversal skills in a slide or two. So our specific task from understanding these new and emerging skill needs was to develop a training program, which in this case was deliverable 2.3. Just to note that the project deliverables are available on the website, that link. I don't know if the slides are going to be made available after, but if you look up the Alchemia website, you should be able to locate them. So we were not looking to reinvent the wheel in terms of the recommendations that we might make and develop a whole new program, but we're looking to develop a program based on existing good practice for the skill needs we identified, specifically focusing on transversal skills. So as it says on the slide, it was specified that the program should cover for non-experts basic AI or artificial intelligence, data understandings, robotics concepts, and the basic concepts of trustworthy and ethical AI. It should also facilitate worker acceptance, ensure the optimal use of federated learning-based AI systems, and guarantee the highest level of trust, safety, and seamless collaboration between workers and technology. So, Tony, you might recognise this from our work on the ESSA project. So essentially, we developed a programme based on pillars, which I cover on the next slide. And these cover different aspects in terms of transversal skills needs that we identified. For understanding transversal skills, we turned to the European Steel Skills Agenda project, or the ESSA project, which identified a range of transversal skill needs for the steel industry. A major European project, the ESSA project, involving direct input from sector stakeholders, so steel companies, steel unions, those involved around research in the steel industry, including myself and including Tony, who's here today. Identified transversal skill needs across a number of categories, which are listed there on the left of the figure. So personal, social, methodological, digital, environmental skills, and these link to sets of sub-skills for each of those: personal adaptability, social communication, teamwork, so on. And we applied this and this thinking to the skills program that we developed. So informed by the thinking of transversal skills, we developed different pillars of research. From the research, we developed different pillars of skills and training needs to inform our good practice program. So pillar 1 offers general transversal skills required for the wider digital transformation of companies. So it's a response to the general skills requirements of the wider workforce arising out of the need to support the wider digital and environmental transformation of the metallurgical industry. Pillar 2 focuses on specific transversal competence requirements arising from the integration of the Alchemia system into specific production contexts. And it comes out of the empirical analysis of actual production processes and anticipated effects of the system on existing tasks and jobs in the companies that we visited. Our analysis suggests that the AI insertion and its subsequent use will only specifically impact a few tasks and therefore only a limited number of staff and workers in very particular and limited ways. Pillar 3, the final pillar, reflects transversal competence requirements related to the operation of the Alchemia system. Our current understanding of how the final deployable system will be operated suggests at least 4 aspects related to specific competence requirements, which all relate to digital competencies. And so the outcome of the program is this. So where I was talking about those 4 competencies just a moment ago, it's about information and data literacy, safety, problem solving, and sustainability. And we can see how each pillar corresponds to a particular set of transversal skill sets, being pillar one being the more general in relation to digital and environmental transformation, pillar two more focused on what we anticipate of digitalization and AI systems more generally, and as I mentioned with pillar three, those four particular sets of transversal skills, information, data literacy, safety, problem solving, and sustainability. And with those, so if I go back just a sec, so with those specific competence requirements identified in terms of the skills needs, then we set about looking for good practice training. So we were of the mind that the good practice training is, or there's training already available that is good practice. So as researchers, we set out to find what we felt was good practice from organizations and websites, and such as Steel University and the Steel Hub, which we worked with on the ESSA project. We're able to identify a range of programs that were appropriate to the pillars that we identified and the skill needs that we identified. And just here is two examples. The full range of examples are in the deliverable 2.3. But you can see here, so this one here we've got for environmental competencies, and three different programs on environmental competencies that whoever wants to take advantage of this training program might go to. And then we've also got examples here for digital competencies. So cybersecurity would relate to safety, and then there's sustainable AI in business. So we've identified the skills and we've connected those up with the with different training programs that those involved in the project may want to access, but when it's rolled out more generally and scaled up for the metallurgy industry, then others may want to access those as well. So that, I think, remember correctly, that's everything. So thank you for listening. And I think, Irina, we aim to take questions now.
Yes, if someone in the audience has any question, please address it by the chat or even verbally. I reserve my questions by the end of the sessions.
Okay. I'll open the chat now. Was there anything in the chat?
No.
No? Okay.
Let's give time to people to think in their questions. Now, the next session, it's future skills for circular wood waste solutions. Why Foresight Matters for Industrial Transitions by George Martins from Wood to Wood project. George Martins is a senior scientist from VTT, Technical Research Center of Finland. His research areas are technology management, foresight strategy, and innovation. Currently, George is focusing on the management of knowledge and inter-organizational networks, diffusion and adoption of key enabled technologies and innovation systems. In the Horizon funded project Boot to Boot, he leads the work package on skills development and standardization, policy, and certification. Please, George.
Oh, thank you so much for the introduction, Irene, and I'll start with sharing my presentation. And hello, everyone. You should be now seeing it in full screen mode. If not, just let me know.
Yes, it's okay.
Yes.
Thank you.
Thank you so much. So yes, I'll maybe be a little bit provocative and maybe start with sharing some insights into foresight, what is foresight, and what we can do about the future. And I think the perspective we want to share is quite well summarized in these sentences, that the future is not predictable. So our aim is not to predict the future, as unfortunately we do not have crystal balls. But we should live with the certainty and accept the fact that there are alternative futures, but we have the agency and the responsibility to shape what the future might look like. So these notions here in the slide, they highlight that the future is not something that is predetermined. And something more important is that we can shape it. So our decisions and our actions today, they will influence which of the futures become reality. So there are multiple futures available to us today. We just have to act on the path that we consider desirable. So considering multiple futures, both those that are likely, because there are circumstances that are more probable, but also considering what is preferred is not just a useful intellectual exercise. It's actually something essential for strategy and for planning. And yes, this process is not neutral. So it involves exercises of judgment. It involves bringing to the surface values, selectivity, choice. All of that comes into play because we are attempting to answer the question of what kind of future do we want? And also in doing that, we are at the same time answering what should we avoid? So these notions are at the heart of foresight thinking. And here we visualize what's known as a cone of alternative futures. And what this tries to symbolize or to capture is that at any given moment, there's a spectrum of possible futures that stretch out ahead of us. And at the widest point, we can consider possible futures. Anything can happen, even improbable events. Here we could place things like COVID-19 or war in Europe. They are possible, even if some time ago we would think of certain of these events as improbable. In the middle, we have plausible futures, and these are kind of based on trends and current trajectories. So maybe some of the things that are more expectable. There's a more narrow aspect to this. That's the probable futures. They are likely and based on the current momentum. But at the final tip, there's preferable futures. And this is what we actually want to happen. And this is maybe where we can have some sort of intervention. And the purpose of futures thinking and typically scenario work is to help us move from probable into preferable, and ideally to take agency in shaping the pathway towards that preferable future. So this is why futures thinking is typically considered visionary to some extent. It involves visionary knowledge. It requires understanding a continuum of knowledge that actually starts in the past. It requires that we interpret the past, but also that we make sense of the present and that we engage with our imagination to explore what's ahead. Again, this is not about making precise predictions, but it's about trying to foster creativity, think differently, and build some strategic capacity to prepare for the change that lies ahead. Now, this is the mindset that we advocate and that we are also applying in the Wood to Wood project. This mindset, we think, is especially critical when we are dealing with changes that are complex or with shifts in specific industrial sectors that are actually of a systemic nature. And that is certainly the case of the transition to circular economy in the wood waste process industries, which are at the heart of the Wood to Wood project. So the project is built on quite a bold mission, and at the same time it's urgent, and that's really to unlock the value of wood waste, especially wood waste from construction and demolition, and also furniture, old furniture, and turn that into a driver for circular industrial transformation. So we're working across the entire life cycle. So from how wood waste is collected, sorted, so looking into automation of the sorting processes, how it's cleaned of any possible contaminants, how it's processed, tracked with the use of digital passport systems, and how it may be reintegrated into new products. which can be composite products, for example, used for building facades, but they can also be surfactants used for the manufacturing of soaps. So quite an interesting range of reuses of what might be contaminated demolition wood. We follow that path towards bioremediating and reusing it. Having this new perspective of what might be a new value chain. So our efforts are really rooted in real world settings and industrial piloting of these solutions. And we think that what makes the wood to wood approach stand out is this kind of systemic approach. We are not just developing and piloting technologies, we are also seeing how these might align with potential future business models, policy instruments, and quite crucially, human capabilities to make this transition scalable and sustainable. We focus therefore on skills because technologies alone don't drive this type of transformation that is needed. People do. People drive this kind of transformation. So as we shift towards circular economy in the wood sector, we are seeing clear signs that new occupations are emerging, and we need to understand more those changes. We need to characterize also the factors of change to anticipate what roles might come into play. So we have to think of roles like circular material designers, AI-driven sorting system operators, experts in digital product passport deployment, just to name a few. But the thing is that the shifts, they can't just be assumed. So without the right skills in place, most of the innovation potential of the pilots that the project is dealing with could struggle to scale. And that's why in the Wood to Wood project, we have a work package that focuses entirely on identifying what capabilities are needed, where the gaps in skills are, and how we can anticipate and shape new occupational profiles. This also connects quite directly to policy and equity aspects. So circularity must be inclusive, and transitions in industry must be equally inclusive. So through aligning foresight on skills with standardization and certification aspects, we hope to contribute to building a workforce that is ready for change and also empowered to lead that change. Our aim in the work package we've been working on is to map how occupations in the process industry will evolve as circular economy principles take hold and continue to be significant going forward. Our time horizon is 2035. And what we're doing in terms of the data that we're looking at is that we're combining expert-led analysis or expert-led input concerning trends and signals of change with also signals of change that we extract from scientific publications and patents in order to develop credible and evidence-based occupational scenarios. These scenarios will, we hope, more towards the later stages of the project, so in about a year and a half, help support stakeholders in aligning education, certification, and policy efforts with the future skills landscape. We ground or anchor our identification of trends and signals in a well-known framework, the STEEP framework, and this acronym stands for these different dimensions of societal aspects, technological aspects, economic, environmental, political, and value-related aspects. This multi-level or multi-perspective framework helps us make sure that we are not too technocentric or too techno-enthusiastic or not too narrowly focused only on technological changes because it's important to account for shifts in social values, in dynamics of regulations, in also environmental imperatives. So when identifying and categorizing both trends and signals of change, we do that through the lens of this framework to compare across domains and try to build a more coherent narrative. So this framework is quite useful to integrate the different data sources that we are using in our analysis. And it's kind of our compass for navigating the complexity that exists in the identification of skills in this sector. Alongside with the expert insight, we are using bibliometric foresight, meaning a systematic analysis of publications and patents to extract early weak signals of what might be emerging innovations. So this process starts with keyword searches and clustering of keywords, and then we're moving on with some AI-supported classification of the abstracts from the publications we're analyzing and data from the patent descriptions. We then are analyzing or assessing the signals extracted from this corpus of data through proposing that in this data there is it's possible to determine the degree of diffusion and intensity of the signals based on the frequency of reference to certain signals. So this can help us determine how widespread such signals are and also how disruptive they might become. And we haven't completed the analysis of this data. It's quite a wide data set, but it seems that there's some strong signals around digitalization in sorting processes, also around novel composite materials, and also scalable bioremediation approaches. These findings will enrich our upcoming scenario development. And so will the contribution from an expert survey that we ran to collect both trends and signals generated by experts. Expert knowledge remains a cornerstone of futures thinking, and we've embarked on the very challenging effort of collecting insights from a very extensive sample of international experts. We've managed to collect responses from 373 international experts across critical domains of expertise. You have the detail here on the slide, but their domains of expertise range from digital traceability, industrial technology, bioremediation, waste management, new composite production, and then also experts that represent knowledge on socio-technical and environmental transitions in a broader perspective, where you would expect to see more the soft skills being represented by the perspectives of those experts. The profiles of these experts was quite varied. They don't originate exclusively in universities or research and technology organizations, although the majority originates there. But there are also industry respondents. There are also civil society respondents from industry associations, from trade unions, from educational providers or training providers. So we balanced as much as possible the profile of the experts we've been we administered the survey to. Now, what these experts did is they helped us first identify and then classify trends according to the parameters of the STEEPed framework that may have an impact, according to them, on skills in this sector. And maturity in this sense means we've asked them to assess what's new, what's established, and what's fading in terms of trends. We've also, in a second part of the survey, asked these experts to identify and assess signals of change. potentially disruptive and impactful factors, again, across the domains of the steeped framework. So what are technological signals that you can identify, and how would you rate them according to their level of your perceived assessment concerning their impact, or their or the certainty with which those signals will be disrupting and impactful in the sector. So this allows us to prioritize which signals actually merit closer monitoring, which ones may shape new occupational needs. So again, this process also will feed into the scenario development stages. So at the moment, because the analysis of the data is ongoing and it will be phased across the project lifeline, and we're dealing with really very vast volumes of data, as you can see from both the structure and content of the survey and also the corpus of data, which the quantitative one at the moment includes patent and publications data, but we will extend that also to look into job data, so job postings, but that will be in another stage of the project. But early survey results so far, they give us also some solid foundation to start building scenarios. And among the sort of emerging trends, we see some momentum around AI-powered solutions, of course, but especially in sorting, in tracking, in process optimization. There's also growing emphasis on integrating bio-based and circular materials both into the design and into the production stages. On the more established trends front, industrial symbiosis and product as a service models, they are no longer fringe. They are kind of becoming common practice. And there's on the other hand, a decline in some linear practices such as manual sorting or single-use materials. That's clearly declining. Concerning the signals, what we are mostly interested on is signals that experts have labeled as high impact and high uncertainty. These are the powerful signals, really, but we know that their trajectory is uncertain. But if they do materialize, they can really reshape the future of industry and the workforce and the skills that are needed. And here we see selected areas of those exemplar signals that we're dealing with at the moment at the analysis stage. Some of them point to shifts in policy regulation, where the perception is that whether there's an acceleration or delays in implementing circular economy policies, this will have a direct impact on either fast tracking or stalling innovation, with direct impact on job roles, compliance tasks, and business models. Quite crucially, some signals converge around breakthroughs in bioremediation, so technologies for treating contaminated wood that can radically change processing workflows. They can reduce health risks. They can open new opportunities for the recovery of material that previously would just be discarded because it would be considered too contaminated. But of course, there's doubts concerning the scalability and acceptance of some of these signals. And then digital product passport adoption is another signal that has been featuring quite prominently in our analysis. But here there are again nuances or aspects to consider, especially around interoperability. And of course, in a scenario of full interoperability, then material tracking and transparency are completely revolutionized. But if the uptake of these solutions is fragmented, then it can also have consequences concerning uneven skill demand, or the system becomes too complex. So this type of insights, they are going to feed directly into our scenario development and help inform future-proof policy and skills strategies. I mean, this it's just the beginning of that stage. So in the next stage of the project, we will use these insights to build those occupational scenarios together with experts in the regions covered in the project. There are about 10 different countries across the EU, plus South Africa. And in those workshops, we will identify key uncertainties around those selected signals, try to develop some logical frameworks for future possibilities, and start imagining how job roles, skills needs, and industry structures might evolve in accordance with those signals that we will select. But that's all from us, from Wood to Wood. Of course, also happy to answer questions right away or to save them later for the discussion.
Thank you, George. Just a practical question. Do you have any public deliverables to go deeper in your research and the answer from your very impressive results on your survey?
They are upcoming. June this year will be the first deliverable. And
Perfect.
it will focus on reporting the analysis of the trends and analysis of the patent data and the publications data.
Thank you. We will staying up for this very relevant information. Yes, we have a question. Please go ahead.
Yeah, maybe one question from my side. Thanks very much for the presentation. And I'm wondering in how far industrial symbiosis is a relevant aspect of your project and your foresight and activities.
In what extent can you clarify more?
Yeah, how you are only focusing on the water sector, or do you integrate also other sectors to see how, let's say, the reuse of materials and so on is possible?
We focus on the wood sector.
Okay. Yeah. Yeah, because I'm asking this because I will show some examples from the energy intensive industries, and their industrial symbiosis is a very important topic, and this cooperation between the different sectors could be extended much more. And therefore, maybe I will come back to you concerning the wood sector.
That's great. Yes.
Well, I think we don't have more questions yet. So now we are going to change the sector. We have been in the steel sector, now in the wood sector, and now we are going to the artificial intelligence tools for waste water treatment plant operators, challenges and impacts by Beñat El Douayen from Darrow Project. Beñat El Douayen is a senior researcher at the SAIT BRTA Research Center in Spain. He has contributed to over 20 projects centered on developing and applying mathematical models in the water sector. Currently, his research focuses on digital twin applications for the urban water cycle. He's the coordinator of the Darrow project, which has the objective of developing artificial intelligence-based tools to optimize wastewater treatment. Please, Beñat.
Well, thank you for the presentation. I will share my screen. Yep. Please confirm that you can see my screen.
Yes, but not in the screen presentation mode.
Yep. I'm getting there. Yeah. No?
Perfect. Thank you.
Yeah. Okay. Well, thank you very much, and good morning, everybody. I I wanted to be a little bit provocative too, as the previous speaker, and I wanted to start my presentation with the next sentence, that is that humans will not be needed for most things. This statement was done by about a week ago by Bill Gates in the Jimmy Fallon show, and despite it was done in an informal atmosphere, I think that the person that made it has enough credit to be taken seriously. Of course, I'm not here to discuss if this will become true or not. In fact, I agree with the previous speaker when he said that the future is not predetermined or predictable. I really like that. My sensation is that we could have a couple of dozen of experts of different fields in a room, including AI experts, engineers, psychologists, philosophers, or yeah, whatever. And probably they will not reach an agreement about how AI will impact our lives in the next 10 years. Of course, because predicting the future is something very difficult, especially in the highly changing environment that we are right now. However, I like this statement because I think that it gives us a hint about the relevance of the moment we are in regarding the AI tools. We all have seen how the AI tools are impacting our daily routine. So, for example, I have stopped asking my students for written essays because I'm tired of reading pieces of work that will be hard to be written for my most experienced colleagues. Of course, it takes me much less time than before writing Python codes and any other daily things that you can do with AI tools nowadays that were maybe very difficult to think about 2 or 3 years ago. However, despite this advance that we are seeing worldwide in many different contexts, I believe, or my sensation is that in some sectors, AI is still quite hyped regarding the impact that it may have. And especially, it's not very clear how it can help or how it will impact the final user. So that's what I'm going to talk about today. I will try to summarize some of the experiences that we are having in our project, in the Darrow project, in the last years. For that, I will focus on the AI tools that we are developing, but especially how are they impacting or how they will impact the people working in the wastewater sector. Before starting with the presentation, I would like to introduce myself. Well, as Irene has said, my name is Beñat del Valle, and I have a PhD in applied engineering, and I have more than 10 years of experience in the water sector modeling and simulation. My research center is CEIT, which is located in San Sebastian in north of Spain. We are a multi-focus research center with more than 300 people working on them. And also, in addition to being a researcher, I teach in the Technical School of Engineer in environmental engineering subject. I'm the coordinator of the Darrow project. The Darrow project is a project funded by the EU with the objective of building and demonstrating an innovative, optimized, modular, and flexible data-driven AI solution to make existing wastewater treatment plants more autonomous and more energy efficient and more sustainable. We have a budget of 3.5 million euros. We are supposed to be finishing the project in 2026. In the project, we are 8 different partners from 4 countries, and we want to implement our developed solutions in the wastewater treatment plant of Tilburg in the Netherlands. I don't know, because I guess that some of you will not, or most of you will not be familiarized with the wastewater treatment plants problematic. So I will give you just a very short introduction to this problem. Wastewater treatment plants are infrastructures that are focused on removing contaminants from water. So that's the main goal of wastewater treatment plants. But some time ago, like a couple of decades ago, there was a paradigm shift in the wastewater treatment plants. So traditionally, we have thought about these infrastructures, as I said, as places where we can remove contaminants. So we have seen them as a pollution problem. However, some time ago, we also realized that wastewater was interesting for recovering different goods as water or nutrients or energy or different things. So this made the process more complicated and also more interesting. And therefore, it made the process, worth of studying and worth of optimizing. To understand the optimization of the plants, we need to know that there are two types of processes. So we have what we call fast processes that were optimized through control and automatization techniques using classic techniques. And also there are other processes that are very slow in their kinetics, and this was optimized, or this is studied through model analysis. On this regard, mathematical models have been around in the sector for 40 years. The problem is that these mathematical models are quite complex in their nomenclature, and they are very difficult to use. So these modeling studies are often done offline by simulation experts. So this has made us, the simulation experts, to be understood as some maybe nerds that are in their office and they are a little bit disconnected of their daily life of the wastewater treatment plants. And it seems that there is some kind of barrier between our work and their daily operation of the plant. Despite the models have been proved to be useful, we have been doing research on mathematical modeling for more than 3 decades now, and we are still being asked to do research projects on this because our sensation is that the operators really value our work and the insights that we are making. We believe that we could do a little bit more and we could bring our expertise and our tools to the operators. So therefore, we need to break this barrier and we need to adapt our tools to be used by the operators in the daily life. Okay, so the problem is that how can we do this? And to do that, our answer, as I think that the same answer has been found in different sectors, is to develop digital twins. Probably you have heard the term before with many different definitions because a lot of people have been talking about digital twins in the last decade. The definition that we are using in the DARO project, or what we are using, is that a digital twin is a replica of the physical system, which is composed of a virtual representation of the system and is using real-time data from multiple sources. So to develop the digital twin, we need a virtual replica of the system. In our case, the wastewater treatment plant. We need to have a real-time connection with the data and have prediction ability. And our virtual tool needs to evolve with the physical system. We believe that if we develop this, we can bring the power of our tools, of the modeling tools that have been used only by simulation experts, to the end users, to the operators. Okay, this idea is not new, okay? We are talking, 2024, 2025 about digital twins, but this idea has been around for many time. The thing is that we used to call this kind of connection between data modeling and the end user as advanced data managers or expert systems before. But we believe that we can finally reach to a product that is going to be used because we have a new kid in town. Okay, artificial intelligence can help to make these tools more efficient, more simple, and that means that it can be used by the end user. We are using artificial intelligence in three different ways in the DARO project. For the replica of the physical system, we are using reduced order models. This helps the end user because the models that we are developing are much simpler than the ones that we had before. So they are easier to use and easier to understand and to follow. We are using artificial intelligence for the connection with the data. We are doing algorithms for fault detection, data reconstruction, data enrichment. So the end user has the information in a more accessible and easier way. And then we are using artificial intelligence for recalibration procedures. So our models are not used once and that's all, but they can be used in a daily routine. The challenges that we are finding to develop these tools are mainly related with interaction with humans more than with the algorithms. We have found different challenges related with the people working in the sector, including, of course, researchers, operators, companies, etc. I'm going to name three. Probably there are more, but I would like to focus on these three. The first one is that we are seeing that there is a lack of real experts combining AI knowledge and process knowledge, and this makes usually communication quite difficult between different agents. We are seeing a lot of developments made by AI experts that are already done before by process engineers, but using other kind of methodologies. So we really need to focus on education of people that will know about both things, both AI and process knowledge. We are seeing that there is some lack of alignment and communication within the organizations, especially when we are talking about end users. Usually, the research projects are being carried by some kind of people that are not the end users. So then the end users are not really listened, and we don't know which are their main needs. We are trying to focus on this thing in the Darrow project when we are holding, or we will hold meetings with the end users, and we will explain our tools in different courses so they can give us their feedback and make our tools more useful. And also, of course, there is some, I think this is common for every sector, and every engineer you ask will tell you that there is data scarcity and probably low data culture, because people used to take the data, but they are not doing it focusing on developing tools, and they are doing it mainly for fulfilling the law. So it's not focused on the tool development. So knowing the challenges, the impacts that we believe that our project and our tools will bring to the people working in the sector is that they will have easy access to information. Nowadays, data is very is in different places, and it comes with noise. It comes with long time. You have to wait it for a long time, and it's very difficult to centralize. So we believe that our tools can help to treat this data properly and really bring information to the end user. We believe that the end user will have online predictions of how their system is going to behave, which is a huge improvement and a huge amount of knowledge that they will have that currently they don't. And finally, we believe that these AI tools can help in the training of the operators, so they will be better prepared for the challenges that they will have in the future. Mainly, the idea is that with the AI tools that we are developing, the workforce, the people in the sector, will be focused on high-level decision making, because most of the tasks that they are doing now of dealing with data or or giving information to other people will be automatized in the next years. So to conclude, I would like to come again to this sentence. Apparently, we will not be needed for most things, but there are some people that will be saved from the hostile AI takeover, including coders and experts of biologists. Some of them are working with us in the Darrow project, so the future might be not that bad. So thank you all for your attention, and happy to answer any questions that you may have.
Thank you, Beñat. I think that we don't have any question. Yes. Oh, no, this is a new one, people coming to the webinar. Okay, so now we have the session from the relevance of skills for the digital, green and social transformation of the steel industry by Antonius Schroeder, representative of 3 different European projects, Skills for EII, ESA project, and SPAR SACE. Antonius Schroeder is a senior researcher and member of Management Board Social Research Center Faculty of Social Science at the University of Dortmund. He's responsible for international research. His focus is on social innovation, combining technological and social innovation, and vocational education and training. He has worked in more than 13 European projects, namely two large-scale Erasmus-funded sectoral, European Skills Alliance, and the large-scale partnership energy-intensive industries under the Pact for Skills. From the next year, he will be coordinating the large-scale Skills Alliance for the green, digital, and social transformation of the energy-intensive industry, Skills for AI. Please, Tony.
Yes, thanks a lot, Irene, for this introduction. And I think it's relevant to say that that we are referring, that I'm referring in the presentation to what was already mentioned, the European Steel Skills Alliance and Agenda, and the Skills Alliance for Industrial Symbiosis, SPIRE-SIZE. And these both skills alliances are the backbone of the skills for EII, the Skills Alliance for the Green, Digital and Social Transformation of the Energy-Intensive Industries. So it's a broad spectrum concerning the industry. And all these activities now are very much supported by the European Pact for Skills. So I'm coordinating as well the large-scale partnership energy-intensive industries there. And we try to join forces across different projects. So I might come back to one to the speakers of today to integrate their perspective and their results also in our developments. Yes, and it's let me say it's not only about skills. It's about the relevance of the human perspective, which is let's say our main mission in the technological development. So to combine the human perspective and the technological perspective in a common development, implementation, and also usage of technologies. So as I said, this is based now very much on the Pact for Skills, the large-scale partnership energy-intensive industries. You see here the URL where you can get more information. So it's very much the perspective across different sectors like steel, minerals, waters, engineering, logistics, aluminium, ceramics, raw materials, welding, chemicals, and cement. And it's very important to remind or to underline that this is based on an ecosystem approach where companies, associations, unions, training providers, research institutions, but also some civil society organizations are working together. But now let's have a look at the technological and economic demands and skills requirements we analyzed. Concerning the technological development and demands, and I'm now focusing on the steel sector and the ESSA project, is that all recent Industry 4.0 technologies are in place. So it's new sensors, big data, machine learning, artificial intelligence, Internet of Things, advanced robotics, etc., cybersecurity, and predictive maintenance, to name a few. And it was also the challenge because the integration of all systems, so sensors, automations, IT systems, and production units are in different dimensions implemented: horizontal, vertical, transversal, life cycle oriented. It's about production process optimization, and predictive maintenance, just to name it as well, is from my perspective also a very future-oriented demand, as well as still knowledge management plays a role, and it's very much on environmental process performance. This leads to green skills. So for the skills needs, this didn't make it easy for us to focus on specific things or specific demands. So we had to consider the whole workforce and the incremental upskilling of existing job profiles. But the main focus, Dean already mentioned it, in the Alchemia project, main focus on transversal skills and an upskilling of the existing workforce. Digital competences mainly were dealt with a buy-in. And recruiting talented people with digital skills. I will come to this a bit later. And this leads to the need of continuous learning, also in an interdisciplinary perspective. We had another technology assessment survey made in 2024, and you see here that in the steel industry, technologies are already in use, and here, for instance, the main topics or the main technologies are cybersecurity, predictive maintenance, advanced process monitoring, control, tracking, tracing, cloud computing might be also of relevance, and energy resource management, monitoring and control. These are the main technologies are already in use. And you see here, the red part is that there is an extension planned in the next 3 years. Yes, and affected skills categories. So we came up with a so-called T-shape category. So transversal skills and specific technical skills are relevant. And I will focus here. I cannot focus on everything. I will focus here in my presentation on digital skills, mainly digital skills. And I just want to remind also about the methodological skills, which are very much linked to the digital skills. So digital skills are basic skills, advanced data analysis, cybersecurity, complex digital communication tools, and advanced IT skills and programming. And concerning the methodological skills, you see here also basic data input and processing, statistical skills, complex information processing and interpretation, and complex problem solving are also relevant. So let's have a closer look at the digital skills. You see here in blue the current relevance, and in red the future relevance, and on top you see the percentages of increasement. We had a we had 4 levels of skills. From 0, if there are no knowledge about it, 1 awareness, 2 practitioner, 3 expert, and 4 master. These differentiations are given by or used by the steel companies in our project, and therefore we related it to it. And you see here that there is the current relevance is about 1.5, so between basic and practitioner, and the future relevance is much more above, or is around the level 2 practitioner and on top. We check these skills also for the future relevance and the current relevance for different job profiles. So we selected 9 job profiles on different levels of the production process. So as you can see here, the current relevance is quite low, was quite low, and the future relevance is increasing. My personal view is that this should increase much more in the future. These were data from 2022. So you see here that the managers have the higher level of competences in this of skills in this digital skills portfolio, but also the factory hand is low, but you see here it is increasing as well. So the digital skills development should be focused on all levels in the company. We ask also which new job profiles are appearing. I have to say that it was a survey where that was dedicated to the experts in the company, the human resource experts, to have who have a background of the practical implications of the new technologies at the workplace. So beside green profiles, you see here IT and cybersecurity profiles, technology and production process profiles, also very much dedicated to digitalization, and also data-related profiles which were named. Yes, and unfortunately, 10 years ago, but I asked my colleague who is the head of the training center of ThyssenKrupp if this is still relevant, and he said for sure it's more relevant than ever to have a look at talent management and to see how far the talents or what the talents are expecting from a great company, let's say it like this. So and you see here that they say that that there are a lot of important topics. So it started from four on within a five level scalar. So from 0 to 5, very important, and you see a lot of things are important for them. So they need the opportunity for personal development, a safe working environment, and the leaders and managers should treat all employees with respect and care. The opportunities for advanced training, not only for hard skills, new job-specific hard skills, but also softer skills. Work-life balance is very important. And then also a good salary, responsible environment development, strategic, creative thinking, and regular feedback, etc. I stop here now. So just to say that the talents we ask have in the steel industry 2015 had a high expectation for their new company. So and this leads us directly to the topic of image and recruiting. The image and recruiting topic raises much more, or very in a central way, in the different steel regions. We had the rollout of our results of ESSA. So we had workshops, several workshops in 9 steel regions all over Europe, in 9 different member states. And there at the place, let's say it like this, the place where people live and work, there the central topic is image and recruiting. And they all refer to recruitment problems related to the poor image of the steel industry. And they stated a need to attract more women and new talents. Unattractive job profiles for new people. They have to face a shortage of skilled students, and poor relationship among companies, universities, and public administration. So that's shows the need for regional, local ecosystems working together on this problem, on this challenge. We also discussed the solutions. To summarize it a bit, there was a strong orientation to develop a new narrative for steel. So highlighting the steel industry sustainability and transformation efforts, and also the adaptation and modernization of job profiles. So not only any more dangerous and dirty jobs, which are characterizing the steel industry. And an improvement of relationship and cooperation in the region, showing more presence in schools and university, exploiting regional potentials by strengthening regional networks, and also to have a look at new and changed target groups. So more efforts needed to attract talents. For instance, by creating new channels of access to the steel industry via social media, and also via targeted measures to involve women in the steel sector. Based on this, there is a very successful activity in Spain, Women of Steel, it's called, where our partner Unicid with the steel companies Chelsea, Sidenor, ArcelorMittal are trying to campaigning much more the integration of women in the steel sector. Yes, and to say that we are based on the results of the projects, we are very active in influencing, let's say it like this, the activities, European activities of the steel sector, and also the energy intensive industries. So the Clean Steel Partnership, just to mention this, and the European Steel Technology Platform, underlying the steel industry-driven proactive adjustment of future skills. So they also underline the importance. And there is in this strategic research and innovation agenda, there is a strong focus to combine information technology with operational technologies and human factors to manage and connect digital infrastructures. New approaches for skills adjustment is needed. Again, the Clean Steel Partnership. So I won't go through these things. You have the time to read it in detail afterwards. So closing the skill gap is very important, but let's say beside the emphasis on digital skills, including AI, programming, and cybersecurity, the future labor market needs have to be adjusted, and providing lifelong learning opportunities tailored to individuals and industries. And that's very important. So we always in our projects say that we are industry-driven, and try to look for short-term solutions. So learning and upskilling here, one point I want to stress very much is to enhance digital learning capabilities of the people. I will come back to this a bit later. So attracting and retaining talents, offering scholarships for STEM fields and so on. So most of you are aware of it. And vocational education and training. So there is a lack of coordination in the VET systems across member states, and this is let's say one of the main challenges, that the VET systems have to be more flexible and more up to date. And I already mentioned, or Dean already mentioned, also our online training platforms. There is a Steel Hub from the ESSA project, and there is the Skills for Planet concerning industrial symbiosis. You can, if you click here, you can see a short video, and you also have the URL. So they are these let's say these platforms are open for every training provider and are open for every training user. So it could be a company integrating the modules in their learning management system, but it could also be individuals. Just one thing that to mention, that concerning the Steel Hub, there is also a so-called Steel Challenge for young students and workers. There is a possibility to simulate steel production, and there is a competition who of the students does it the best. And up to now, there is the running also a national steel challenge in Spain. And we will go much deeper in in the possibilities for recruiting new talents. So we have a sustainable future steel production and people recruiting and skilling project, which starts in summer. This project is called Super, and it is bringing together industry and talents. So it's a program for about 40 participants from different nationalities, including training and visits of industrial sites and research locations. So they can get a practical insight in different steelmaking processes, decarbonization challenges, and yeah, it's a possibility to change the image and perception of the steel industry for this talents. So we are looking very much forward to it, and this will be, I guess, 1 week in the region of Krakow in Poland. Yes, last but not least, an outlook to skills for EII. This new project bundling the different projects before in this direction. And I just want to underline or show you a bit about the program we are looking for. So we have a work package on skills intelligence. And this skills intelligence on demand and supply, demand, technological demand and skills supply, training supply is focused on, for sure, technological needs and skills demands, but also on Industry 5.0. Industry 5.0 in the way that we are focusing on human centricity and the relevance for sustainability and resilience as well. We have a cross-sectoral aspect, which is on industrial symbiosis, energy resource efficiency, image and recruiting, train the trainer, digitalization and artificial intelligence, transversal skills, and skills 5.0 for the Industry 5.0 orientations. And these three pillars are the background for the further training development. So there is, beside the cross-sectoral training, there is also sector-specific training and rollouts. And up to now, we have the steel industry, minerals, ceramics, water, raw materials, engineering, logistic, chemical, aluminium, cement, refinery on board, but we reach out to further sectors, pulp and paper, for instance, and glass is also of interest for us. So this was one of the main results of the former project, to focus much more to the sector-specific demands and deliver solutions for it. And we will focus much more, based on the results of the former project, on the national regional rollout. So also marketing for the solutions and tools we developed, that they could be distributed much more to the national and regional level. We will take up the two online platforms, training platforms I already mentioned, and we are looking for a common solution to cross-fertilize the different trainings and possibilities. And we will focus very much more on micro-credentials as examination, accreditation of the training modules that should help the individual learner to show his or her portfolio a bit better. Yes, and now I stop. I hope I was not too boring and too long. So here you find all the relevant information and URLs where you can get detailed information. Thanks a lot for your attention.
Thank you very much, Tony. So now it's time for the audience if you wanted to address your questions. While you're thinking, let me thank to all of our speakers for sharing without so relevant knowledge. And I think that we have been discussing a lot of interesting topics. And if we don't have questions yet, I would like to address a very hot topic on this day. And for one of the speakers, Tony was mentioning Industry 5.0. What do you think about the development or even the acceptance of this term nowadays? Because we are still talking about Industry 4.0.
Maybe I could start if you allow. Yeah. So I think it's the Industry 5.0 concept is very much proposed by the European Commission in the last years, and I think it's for me it's very helpful to have this new perspective on the Industry 4.0 technologies. It's very important to realize that this is not a new technological revolution from 4 to 5.0. It's a concept looking at technologies and organization from a human-centric perspective. So it's changing the socio-technological perspective much more. The most in former times, or usually technology is on top, and then human and organization are related to it. And now it's the other way around. Human centricity is on top, and then how can technology be developed to solve societal human problems and organization as well. And therefore, I like this concept very much because it forces a kind of paradigm shift much more from what is technologically possible to which technologies could solve which societal challenge and problems, and how should we organize this. And that really shows also the former presenters are showing it that it's the people who have to use technologies, and it's the people who are impacted by the technologies.
Okay, so can I come in, Irina?
Yes, of course.
I wasn't sure if you were going to speak or not. Yeah, I mean, I think it's as a set of principles, it moves us away from, or attempts to move us away from, technologically determinist perspectives on the way we might organize production, implement technologies and such like, so that we get more of a human-centered way of manufacturing, human-centered, moving us towards human-centered manufacturing. And I think we're incorporating some wider standards and frameworks to facilitate that within Alchemia. So we worked to the standard, the international standard, not that I can remember the exact number and title, but the international standard for human-centered design. And that was the first part of our recommendations, or part of the recommendations from our first report and deliverable for Alchemia. And human-centered design is meant to, the standard is divided between users and stakeholders. And so that sets up some dangers in itself, but in users, at least it's acknowledging that users should be having a say about the implementation of technology and the design of technology. And we've looked to do that through the Alchemia project, through our human factor research, and both in an ex ante and ex post way, so that we can incorporate attitudes towards technology prior to insertion and implementation, and then post insertion, in the hope of, as you know, Irina, with our beta versions and our gold versions, to have some user engagement with the technology in terms of its design. Of course, what might be one user's preference might be not the same as another user's preference. So there are always tensions there, and there are always going to be tensions between users and stakeholders. Stakeholders being those that are the firms and the management and the designers of these things. So those things need to be acknowledged. I think even when we're moving towards a human-centered design, where the tension might have been previously between the technology and the human, there are also tensions between humans in human-centered manufacturing and human-centered design. And the other aspect we look, which I think is also bound up with the principles of Industry 5.0, is trustworthy AI and the frameworks that are developed to ensure that whatever technology is implemented, or artificial intelligence technology is implemented, that it's trustworthy. So we've got Altai, which is the high-level group framework, which we within Alchemia are looking to align with. But there's no framework for compliance. It's not about compliance. That has actually come out now in the Artificial Intelligence Act of the European Commission, which Alchemia should, I guess, be working towards, but that came in later. So we're still working with Altai and trying to ensure that Alchemia platform aligns with the ambitions and the framework of Altai, which we're making good progress with, and we've got a system for doing that, which Tony has been implemented by Martin. So that seems to be working well. So yeah, I think I admire the principles of Industry 5.0, and in a sense what underscores it, but nonetheless it creates its own tensions, I think, is what I'm trying to get across, that we also need to be aware of. And a recent paper that we put together based on human-centered design and submitted to a journal picks up on those differential power relationships that people have in relation to human-centered design, and argues that they need to be acknowledged better, or at least points to the gaps within human-centered design standards and things like Altai, which really, I mean, if your manager is telling you we align with Altai, that is really, you're just taking that on trust, essentially, as a worker. Whether it actually is meaningful in terms of the AI being ethical is another question. So there are always questions to ask in terms of the kinds of different philosophies and principles that we might ascribe to, and the ways in which we might implement them. I think would be my long-winded answer to that question.
Thank you, Dean. Well, we're talking a lot about technologies, and technologies created by human, but also for human. And I would like to make to Beñat a question related to this. Based on your experience, how is artificial intelligence being accepted by the end users?
Can I just interrupt, Irina?
Oh, yes.
Because we've got a question.
Oh, sorry.
A hand up from Luca, who I used to
Oh,
work
yes,
with.
please. Look, we can leave my question for later. Luca, please go ahead with your question.
Hi, everyone, and thanks to all the speakers for the very interesting presentations. I was already familiar with some of them, and particularly with the ESSA project, in which I worked with Dean and Tony. And so my question is for Jorge. And so if I understood correctly all your presentation, your project in the wood sector also relates with skills needs, right? So you anticipate occupational scenarios, but then you also aim to derive skills needs from that. So I understood that the structure, your methodological approach to derive these occupational scenarios is very structured and very precise. And because you look at signals and trends, emerging trends, and from that you start to build these occupational scenarios. And I'm not sure, perhaps I was distracted, if you mentioned then how you derive skills needs from these occupational scenarios. Do you already have a methodology for that, or is something that you will build up later in the project? You mentioned something about using or looking at job postings, right? So perhaps there is an intention to extract information from job postings to inform your skills needs assessment.
So the way in which we envisioned the methodology is that there's different sources of data informing and feeding the occupational scenario development. And that is the kind of structured data that comes from the analysis of patents, the analysis of scientific publications. Job postings will come as well. We don't have them yet, but they will come. And also what is expressed in popular media about transition trends and perceptions of some of these technologies. Now, we don't think that it's necessarily a second-hand inference or information that we collect from these signals of change across all of these dimensions, social, technological, values related. They will be ingredients to be used for the design of the occupational profiles. So when the type of data that we get from the analysis of publications, they will tell us where the frontier of knowledge, scientific knowledge is, and from there we can infer what type of skills will be related to those. And the same thing with the patent data, and that is then reinforced or triangulated, I would say, with the perspectives that we captured with the survey with the 370 plus experts. In the underlying thread of questioning them to identify signals and trends has always been, think of what will be the impacts on skills and occupations in this sector. So whatever we get from all those ingredients is always has this prism and this focus on skills and design of occupational scenarios.
Okay, perfect. Thank you. Are you also planning to use a specific skill categorization like ESCO or something similar in order to, let's say, put some order in the different skills needs that you will be finding?
We are reviewing skills frameworks. We are quite interested in this wide or long T approach. We are revising those. We don't know yet how we will categorize those skills, but we would like to be creative in the design of those occupational scenarios and skill mapping related to those occupations that will come out of the workshops. So again, that will be, in terms of how that stage will develop, it will be participatory, and it will, in essence, recreate a little bit the profile of the experts that we've consulted with through the survey, but in a much more applied sense and in a smaller scale, of course, because the workshops will not have as many participants as the survey. But essentially, we want to capture the perspectives of industry, of science and technology, of civil society with trade unions, and of skills provider institutions that provide skills, and citizens themselves. So we want all those perspectives captured. But to answer the question on the framework, we don't know yet which one we will apply. Right. Or we have ideas on how to extend existing frameworks, but we don't want to make that commitment yet. At least not until we have the full analysis of the data.
Sure. Of course, understand. Thanks for your answer.
If we don't have more questions, I would like to recover my previous question to Vignat. I was mentioning that, okay, technology is created by humans, but also for humans. And based on your experience, how artificial intelligence is being accepted by the final operators or the end users?
Okay. Well, thank you for your question. I think there's I would say there's a mixture of sensations with the AI. I believe that there are people that are very skeptical with it because they they haven't seen really how they can impact their daily life. That's something that we are trying to do in our project, but engaging the end users through courses and by listening to them and having their feedback and trying to understand their needs and how our tools can improve their operation. And also, I think there is the other way around. There are people that are very hopeful that the AI will have the impact that is in their sector, that in our sector, that is having maybe in other tasks that we are developing or that we are doing in our daily life. So I think that this we will see which is the real impact as we walk the way of developing specific tools for each sector. In our case, we are doing this and we are seeing that it can improve some of the things, but other things that like some processes can be improved through AI, especially when we are taking many data into account. But all things are already solved with more simple methodologies. So I think it's a mixture of both of hope and skepticism. And I think that people will come to a medium way, to a compromise between both of them as technologies are being developed and implemented in the sector. I don't know, maybe if this is the same with other sectors, but yeah, I think this is what we are having right now in the water sector.
Thank you. And I also want to point out, what do you think about how the artificial intelligence can help to attract young talents to these sectors that are not so attractive as other ones?
Yeah, well, for example, yeah, I'm a teacher in the university in a school of engineering, and I teach in courses that are not chemical engineering or environmental engineering, who are more prone to come to our sector. So I think that this kind of tools or yeah, this kind of methodologies can attract people that come from other degrees that may have a great impact in our sector. You know, like people from mathematics or industrial engineering, mechanical engineering, people that are more or IT sector, people that are developing tools for other sectors that can come to sectors like the water sector that maybe they weren't thinking of working before these tools appear or before they knew about the application of AI to the water sector. But again, and this is a challenge that we were having and we are having in the water sector, these people that is coming from backgrounds that are different from the environmental engineering, chemical engineering, chemistry. I think that it's important that there is an interaction and a training for them too in the process engineering in our sector. Because if not, the tools that they will develop or the ideas they will bring with will not be useful for the end user. So I think that there is a big need for interaction between experts or between students that that have knowledge on artificial intelligence, or people that have knowledge on artificial intelligence, and people that know about the sector, the process itself. So yeah, it can be good for attracting people, but still, these people need to talk with the people that has the knowledge of the end users.
Yes, this is something that already mentioned Tony in his presentation, with some ideas or even actions to attract these young talents to sectors. I don't know if Tony, do you want to add something about this topic?
Yes, for sure. Let's focus much more on the vocational perspective, vocational education and training perspective. Some weeks ago, in another project called Bridges 5.0, we had a workshop in a steel company with apprentices and trainers, teachers within the framework of the dual system in Germany. So young people very much focusing on vocational education, on the vocational perspective. And there were two things we discussed. One was the acceptance and usage of digital tools. So it was not directly on artificial intelligence, but to use digital tools, especially for their education. And the young people, and they are using, everyone has tablets, and they are using online learning integrated in on-the-job learning, online learning supporting on-the-job learning. And the young people said, we do not want to get any paper documentation anymore. We want to have it digital. We want to use it when we are on the tram back home, on the weekend or whatever. If you give me written documents, we don't read it. So also the documentation of the different machines and so on are already online there. So that's one point, showing that they are really interested in using these digital tools. And they also said that what they realize on the job by on the job training, that they do not have, and that's for sure, do not have the workplace experience of the elder people. But they have digital competences, so there could be a very good win-win situation. The elder people exchanging their experience, and the younger people helping them to use the digital tools. So that was let's say, and they said, and this made it attractive to go for a job in the steel industry. And another one is that within the ESSA project, we developed additional qualification module on the job with some digital elements on additional qualification for hydrogen use. So the company is now not planning. They are building a direct reduction area for the use of hydrogen, and the young people, and it will be open in 2027 or I don't know, but the young people entering the steel company, some of them are already getting this qualification, so they could integrate their perspective on the future steel production very, very good. And this shows, I was really impressed how enthusiastic the young people are. Were talking about these kind of possibilities to have a qualification for future sustainability, and also to use and integrate digital elements in their daily work.
Please, Jorge.
Yes, I just raised my hand so I wouldn't forget to add a couple of points to the already excellent points made by my panel colleagues. It's just that to me, it's really important to capture the dynamics of replacement and augmentation that, of course, these AI tools bring into the workplace. And connecting specifically with the point you were making, Irene, about the younger generations, definitely we have to conceptualize quite carefully what augmentation will look like for the younger generations, especially knowing that concerning lifestyle trends and aspirations of these generations, they have on top of their list in terms of priorities or concerns, things like health, well-being, work-life balance, where we see huge potential for AI to have an impact on these dimensions that are given immense value by younger generations. So in the Wood to Wood project, we want to maybe capture that also in the occupational scenario development, especially through interrogating what does meaningful work look like in the context of using these tools, because the very meaning of work and professional identities are very disrupted. So especially for younger generations, what will be the meaning of work and what will meaningful work be for them? I think these are important considerations because these are things that are changing radically.
Completely agree, George. I think that the meaningful work, at least the purpose, it's something that it's not only followed by the young generation, even all of us, we also are looking for a purpose in our daily routines. If not, it's very difficult to wake up every morning with enough encouragement.
Yeah, I mean, I completely agree with that meaningful work statement and decent work, representation, wage, salary, but interesting work as well, with levels of autonomy and discretion in the work, which, you know, AI as a technology, it can, in the spectrum of it, can go from narrow intelligence to super intelligence. It depends what kind of AI is being implemented and inserted and what that will mean for work and whether it will actually augment in a positive way or otherwise de-skill and lead to the kinds of cognitive complacency that might arrive with decision making being taken away. So it is about keeping that work interesting. But first, you've got to get the people in there and have the industry attractive to people. And I know with the work we've done with, I've done with Tony before, both with ESSA and with the Steel Careers project that preceded that, you know, attracting a more diverse workforce. So, Irina, you're a woman who works in a steel company, but you know, within administration, I think, but like on the shop floor, it's the fewer and far between. It's an aged workforce, and unless things have changed, Tony, since we last worked together, I think there's still a recruitment issue to the industry because it's still characterized as dirty, noisy, hot, despite people working in pods now and working with the newer technologies, working with artificial intelligence, working with big data, with predictive maintenance and such things. And I'm not sure how successful so far the steel industries, at least, are getting that message across that it's a different kind of industry which will allow you to work with new technologies and create more interesting work for you. I don't know, Tony, if you think things have changed much. I guess not, because you've got your super project, haven't you, which is attempting to tackle those issues.
Yes, exactly. And the philosophy behind it comes from the Steel Sector Careers project, where we interviewed more than 2,000 job seekers. and it appears that the image yes, the image of the steel industry is very different from between the people who are have already experience and contact to the steel industry, and they are more positive than the others. So it's necessary to attract young people and to attract talents to make some basic experiences in the steel industry, I guess. And I don't know AI in how far I cannot judge this in how far this AI tools are integrated in the workplace activities. But the other colleagues are more near to this topic, I guess.
I think that we don't have any questions from the audience. If not, let me use these moments for a kindly reminders. As we have mentioned previously, this is the first episode of a series of webinars for the cluster React. So please, I would like to ask you to follow the social network of the different projects that we have been presenting today in order to be updated for all of the webinars, but also for having information for the results that these projects are going to have during the next month. Some of them are going to finish this year, but other ones will start. So please, as all of us are involved in European projects and you know the importance of the communication and dissemination activities, I would like to ask you to follow the social network projects. And I also would like to mention that all the presentation will be available in the Alchemia website. And last but not least, thank you to the speakers for these interesting panel discussions. And I hope that it has been interesting for the rest of the audience.